Hello, everyone. Welcome to today's lesson. In today's lesson, we have a simple task of looking at the assignment that was given in lesson 3 of coordinate geometry 1. And the assignment is exactly what you have on your screens. Okay, so 3 questions. The first one, we are asked to find, the line parallel to this and passing through this point. Okay, the second question, the same line, the same point. This time around, you are finding the line perpendicular its equation. Okay, so, and the last one is the point of intersection. Okay, so quickly, let's go and have a look at what the solution together. I'll walk you through the solution just to save time. Okay, as usual, I told you anytime a question is given, the first thing you write is solution, so that we'll know where your solution starts. I'm not even interested in the questions that you write. I'm interested in the solution, so give me the solution. Okay, so when you are capturing, you can choose not to capture the solution. And when you are writing the questions, you have to write all the questions, okay? And you also, when you are providing the solution, you provide the solution all together. So don't separate them. I've been saying this times, okay, with that number, but some of you still are doing that. So I will emphasize, okay, by repeating, okay, that. Okay, so now, okay, solution first, major question number 1. Okay, questions are numbered, and this question is numbered. So then you go and extract the information. So you extract the equation of the line per experience. You know that you need a gradient from this equation. So meaning you have to work on this equation. So you call this equation 1. Then either comma, remember I said, you can write end, you can write semicolon. Remember I told you, comma, in math can also mean end. Column, semicolon, something to separate whatever that you've extracted here. Okay, take note. So then this will be your point that your line passes through. You can choose not to write passing through this. You've extracted, you know that the line is passing through this. So you know what this information is depicting. Okay, then now, you are asked to find the equation of power line. So you write equation of power line, okay, is given by, but remember, when I was teaching you, I decided not to write the given by because I realized that, okay, what I'm going to write will be full of, okay, so I can still make my point, cut it short, okay, by writing equation of power line, then I bring this word column, then I quote the formula. So the formula will be this, and I've told you, quote the formula first and let the formula lead you. So after quoting the formula, I ask myself, in this formula, what do I need? The parameters. I need x sub 1, y sub 1, and that is given. That's the point that your line is passing through, or your point that, okay, lies on the line. So x sub 1 will be -1, x sub 2 would be what? Sorry, y sub 1 would be 2. Okay, so now what is left is m, which is not given directly. Indirectly, once we know that the line is parallel to this, it means the line and this particular line, the given line, they will have the same gradient. So I'm going to find the gradient of this line. That's what I'll have and substitute. So in this case, what do I do? In order to find the gradient, and some of you, this is what you do. Remember we said, don't just extract the coefficient. We didn't say that step 1, extract the coefficient of what? Of the x as what? As the gradient. The very first step is to make y the subject, or write your equation in the form y is equal to mx plus c, the gradient intercept form. You have not written it in that form, and you are picking the gradient. So I was wondering, you get it? Okay, so as for this one, low hanging marks, we shouldn't lose them. So some of you wrote m is equal to what? From 1, m is equal to 3. How? Obviously, you know that was a misconception. Okay, and we have to make y the subject first. So I will come and make y the subject. Making y the subject, y term here is negative. So I will move it here and bring this one here. And that will give me 2y is equal to 4 minus 3x. So still y is not made a subject. So I cannot extract this, okay, as my gradient. Take note. Y must stand alone. The only coefficient should be 1. And the only number being added should be 0. Shouldn't see anything multiplying or adding. Okay. Then what do? You divide through by what? 2. And I've said because you have one side to be more than a term, you can always do that mentally. So this over 2 will give us y. Okay, this over 2 will give us 2. This over 2 will give us -3 on 2x. So at this point, I have made y the subject, and my terms are explicit. So if you wrote it as a single fraction, you cannot straight away extract your gradient, which some of you did. Okay, remember, if you can extract the gradient, you have to write it y is equal to ms plus c. So you should have two terms here, not a single fraction, which is a term. So if you wrote it as a single fraction, then you are supposed to come and separate before you can get the coefficient of x. So in this case, the coefficient of x becomes -3 or 2. Okay, take note. And once we have this, we know exactly what to do. Okay, we just go and substitute our m. Because we didn't know the m, that's the moment I couldn't carry out direct substitution. So we now know all the parameters. Go and substitute, and the rest will just be all the. So with this one, you clear the fraction. So you multiply through by 2. So this one by 2 will give us this one by 2 will give us this one by 2. Okay, the 2 will cancel. So we'll be left with -3 here. This. Come and expand. Okay. And remember, I said this. Your equation must be left in which form unless otherwise stated. Can someone help me? Hello, are you with me? Which form should you leave your equation unless otherwise stated? Okay, Amma.
Standard form.
A standard form. But in the standard form, you know which term comes first. The S term followed by the Y term followed by your constant. But make sure that your S term is positive. I said all this. We've done enough example concerning this. So if you fail to put your answer in that form, what do you expect me to write? Okay, but be more careful. Okay, than before. So here, if you leave your answer at this point, you know. And when you are moving to, you have to be very careful. Use the term in X to move. If the term is positive, maintain it and move the others to, okay, this side. However, it's negative, so you are going to move these two terms to the side. But make sure that your first term will be X, your second term will be Y term, and your constant term will be your third term. So I will move. So that will give me exactly what I have here, 3x. This is still positive here. Take note. So it will be plus 2y because I didn't move this. Okay, it's only the ones that you move that change sign. Then you equally move this. So you are going to get -4 plus 3, which will give us -1, and it's equal to 0. So this then becomes your equation. Okay, your equation should be devoid of fractions, devoid of brackets, and if you can reduce, you reduce. But everything to one side equated to 0 as well. But the S term, if there is an S term, should always be positive. If there is no S term and you want to start with a Y term, that Y term must also be positive. Take notes. All right. Okay, so that will be it for question 1. Any questions? Okay. If not, then I'll move on. I have addressed all the concerns that I remember. Okay, so now let's move on to question 2. Question 2, similar question, only that this time around we are finding the equation of the perpendicular line. So you extract the information, and I've told you how to extract, which is exactly what I've done here. Then you put this power line, will do the formula. So put the formula and let the formula die. So equation of the power line like this. Okay, and this is what I want you to do. Okay, in some books, you see if the gradient of the original line is this, if the gradient of the parallel line will be -1/m, and you go and find it. Please don't do that. I knew that was there, but I didn't teach you that one because I know that that is not the ideal way of looking at it. So just quote your formula. The formula has the perpendicular, okay, line situation considered. That's why the gradient here is -1/m, because the gradient of the perpendicular line will be negative reciprocal of the gradient of the original or given line. So that's what you've extracted here. So if you find the gradient of the original line, you are good to go. Okay, as for your x1, y1, I've already explained. So now, come and again, take 1 from 1. Go and make it. Now remember, I told you that anytime you write from, okay, do you repeat the same equation? Can I write from 1 and come and write exactly the same thing here? In our previous meeting, I think I emphasized, okay, as to what to do in that situation. True or false?
True.
Right. Immediately you write from, it means whatever that you are going to write here shouldn't be exactly the same as it's something the transformed version of whatever you. So it means you work on it. Okay. If you write taking, when you write taking, that's when you extract exactly what you have there before you come and work on it. So please take note. I've repeated for, I don't want to see this in the class test. Okay, if you do mistakes, do new mistakes. It shouldn't be old ones. Other than that, you are not progressing. Okay, or you are not progressing. Okay, so from one, you come and make your, so the same thing that you do here. Here, okay, could we have inferred from question one the gradient? Could we? Because you knew it's the same equation that you are going to find the gradient. So could you have said that but m is equal to the inferred minus 3 on 2? Can we do
Yes,
that?
please.
We can infer.
Yes, please. At
Okay,
least they are giving the same question.
okay, all right. Please take note. You cannot infer in this situation. Remember, I told you, if you can infer, then it should be from the same major question. So you can see that question 2, okay, question 3, they are different major questions. So question 1, different major questions. So you cannot infer, okay, maybe you are solving question 2. There is an information in question 1. You cannot infer because you are making your inference from another major question, not from the same major question. Is that clear? If this one was 1A and 1B, it's the same major question 1, so you can infer. Is that clear now?
Yes, please.
I guess my point is well made. So take note of that. Okay. So at this point, you come and substitute. Okay. So substitution all the way. Okay. And when you substitute, you can see that the negative and the negative here will cancel. So you have 1 over 3 on 2. And please take note, this is not the same as the concept that I taught you, where I said if you have a fraction over another, okay, whole number, what you are supposed to do. This one is not, it's a whole number over a fraction. So it's different from A over B all over C. This is a fraction over a whole number. Okay, it's different from A over B over C. This is a whole number over a fraction. So what I taught you was not this that I said you can bring this one down. Do you get my point? To come and
Yes,
multiply.
please.
So please, here, you can bring this one down to come and multiply. Take notes. So 1 over any number is the reciprocal of the number. As simple as that. So that's a concept you should have. So 1 over this will be the reciprocal, which will be 2 on 3. And again, you come and clear the fraction, multiply through by 3, which is the LCM. Okay, don't expand. Okay, clear the fraction before expansion, if possible. So give us 3y, this times 3 will give us, okay, 6, so minus 6, and this time 3 will cancel, and you end up getting this. You expand, then you move. Okay, making sure that your x term is what's positive. However, before you move on, check if you can reduce, and you realize that this equation cannot be reduced because we don't have common factor, numerator factor apart from 1 to all the terms. So this will be it for question 2. So now let's go and look at our last question, which is question 3. Question 3, we were asked to find the point of intersection. Okay, so you know if you want to find the point of intersection, you have to solve equations simultaneously, or I taught you another way. Write each equation in the gradient intercept form, okay, or make y the subject in each equation, then come and equate the two, okay, resultant equation and solve for the x. Then you use the x to predict your y, to solve for y. So at this point, what do we do? Write your first equation, you label, and your second equation, you label. Okay, listen to the equation and see whether elimination would be best or substitution. If elimination would be best, then you see the same numbers, okay, coefficient for each of them. Maybe if I want to eliminate x, okay, x should have the same coefficient. If I want to eliminate y should have the same coefficient. Same coefficient, neglecting the signs. Okay, however, no, you can see x or y, we don't have the same, okay, coefficient. So it means elimination, if I want to eliminate, I have to multiply at least one equation by a constant. So I go to substitute. Okay, for substitution to be ideal in any of your two equations, you should be able to make a variable the subject which will not contain a fraction. And surprisingly, some of you went for the change of subject that would need fraction. Immediately you do that, unless you cannot avoid fraction. I've told you, if your change of subject, you cannot avoid fraction. But if you can avoid, never take any variable the subject that will result in a fraction. Go for the one that will not result in a fraction. Please take note. So it means it is equation 1 that we can work on. Do the change of subject, either x or y. You can make any of them the subject. It will not involve a fraction because the coefficient is either 1 or -1. So the denominator of that fraction will always be 1. So in this case, what do we do? I decided to make x the subject. So I maintain this x and move this one here. So either 3 plus y or y plus 3, the same thing. You call this equation 1a. Go and substitute that one into equation 2. Then you solve for what? Your y. Okay. Tread cautiously. And I've told you, don't let this take one line from. Don't let this take one line. Even yesterday, I repeated it. Okay, but the obedient ones decided not to do it. Okay, all right. So now, this is what we have. Label this equation. Any equation that you are going to substitute, give it a name. Okay, and go and write exactly what you have there. And please, your equations are circled. So if you come and write 1a into 2 without circling 1a and 2, okay, obviously there is a missing link. The name of your equation is what you are supposed to indicate there. So if there are 2, you put it in brackets. Let's say this is how you labeled your equation 2. When you are coming to write it here, you should also label it as 2. That's how you write it. It's my point well made. So always, okay, use the exact name. Don't change it. Okay, anywhere. Okay, so that will be it. You substitute, you get x. And you cannot conclude with y. You can't conclude with x. The question asks you to find the point of intersection. So those of you concluded by saying, therefore, y is equal to this. You get here, therefore, x is equal to this, and you end there. Okay, I don't know what the plan, because I cautioned in our previous meeting. So please take notes. Okay, learn from your mistakes. It's good to make mistakes. Learn from it. Okay, but it's very bad to repeat mistakes. Take notes. All right. So at this point here, I think it's even happened to me, and I had your attention drawn, or whatever I told you. Please, the fact that you found y first doesn't mean that's the first value. Okay, remember it will be x, y. X coordinates, y coordinates. So it's the x that you write first, followed by the y coordinate. So please be careful and protect our marks for us. And I've told you always maths before English, or English after maths. Okay, so take it. And that will be it. Okay, if you don't have any questions, I believe I have addressed all the concerns that I so remember. Okay, however, if you have any pending concern, please bring it up. Let's discuss, let's clear that before we move on to our next lesson. Are we all fine? Okay, great. Then, okay, we thank God for a wonderful lesson. So let me see.